Lots of projects call for perfect octagons like on the face of this clock, and this can easily be done here at the table saw if you have the right setup. So let me walk you through what I would do to get an octagon like this cut so it comes out just right. First off, let's start talking about the material. My preferred way to make this is to start with one long piece. So I've got one piece, in this case of oak, that is long enough to make all 8 pieces that I want for the clock face. Now notice that my parts are lettered. What that tells me is the sequence in which they were cut. So see how the grain comes back together on those. I'm going to pay attention to that as I cut my angles and then later as I assemble my parts so that I get some amount of grain flow through them. Now admittedly, when I cut the angle out, I'm taking some wood away, but still by paying attention to this, it's a nice little detail that is going to help make the face of your octagon look a little bit better. I've got these cut in length really, really close to what I need for a finished length. Same thing, I want to make sure that I take away as little grain as possible so that I optimize the flow when I put my clock face back together. Here at the table saw, we need to figure out what it is we need in order to make an 8-sided object. So if you take a calculator and you take 360 degrees, the number of degrees in a circle, divided by, we're going to have 8 sides, which means 16 different mating components. That's going to give you 22.5 degrees. In some cases, it's embedded right onto the tool. So in the case of this miter gauge, it says right here, 8 sides, 22.5. Now, what you do want to do is make sure that your miter gauge is accurately set up so that when I swing over here to 22.5, that's the angle that I'm going to get. So I've taken the time to set up my miter gauge, make sure it's cutting perfectly, and then what I know is that when I come over here and I lock in at 22.5, that's exactly what I'm going to get. Now the first step is to get our boards on here, get one end of every piece cut, then we'll flip and have a look at getting them cut to their exact length. Now for our next step, we want to guarantee that they all come out identical in length. So I'm going to be flipping them end for end, using this flip stop in order to lock that length in. Now part of the key to this with any flip stop is that it's possible for the long point of an angle to work its way under there and over time that flip stop to climb up. So you want to make sure that, like this one, the flip stops, once it's down, is going to stay down so that that length setting doesn't change on you. Otherwise, you're going to lose your accuracy. I've got to sneak over just a little bit more right there. Now I'm going to come back and make the second cut on all of our parts, and then I'll show you just how well this octagon is coming out. Now that I've got my parts in this band clamp, you can really see a couple things here. One, how nicely all the joints close thanks to the good quality cuts we got off the miter gauge. Two, the grain flow that we get around this. So the pattern does kind of follow as we work our way around the octagon. Of course, until we get back to the last one, my H piece and my A piece, because those are the extreme ends of my original board. If you need to profile the edge of a board like this, the edge of an octagon, like my clock has, it's better to do the glue up first because then it's real easy to use the band clamp, then route the edge after the fact. So you can see that using your table saw and a miter gauge that's well tuned, it's easy to produce perfect joints on an octagon like this one, whether you're making a clock face or some other project that's going to stand up very well over the test of time.